Today I'll be talking about the differences between disaster recovery and disaster prevention, and why you might want to adopt a disaster prevention mindset. To start with, what is disaster recovery? In my experience, disaster recovery means hoping that something won't go wrong, but having people in place who know what to do in the event that something does go wrong. And unfortunately, it doesn't always work. Studies show that 80% of businesses, large or small, that enter a disaster scenario without having any plan in place fail as a business. And between 40 to 60% of small businesses fail altogether, even if they do have a plan in place. And to give you an idea as to how costly downtime can be, for large organizations, it's estimated to be around $300,000 an hour. I'd like to discuss some of the drawbacks of disaster recovery and some of the benefits of disaster prevention now. Disaster recovery requires that you would have some kind of secondary infrastructure to support your primary infrastructure. That infrastructure may or may not be idle, but you'd somehow need to keep it up to date such that if the primary infrastructure were to go down, your secondary is ready to go in the event that the primary does go down. Now, from a database perspective, what does this mean? How do you keep primary and secondary data in sync? And what does your secondary data center look like once the primary has gone down? What do you do when the reverse happens, when you have to fail back to primary? Do you take all of the data that was accumulated during the disaster period and port it back to primary? Backups will become the determining factor for your RPO, your recovery point objective, the amount of data that you can tolerate losing during that downtime period. So how about disaster prevention? Disaster prevention, I would argue, is cheaper to run than disaster recovery, and it's actually more economical. In the world of disaster recovery, you're hoping that a disaster doesn't happen, so you're creating idle infrastructure to fail back over to. But in the disaster prevention world, your infrastructure is what saves you in a disaster scenario. And disaster prevention is also great for scaling. The more nodes you add, the bigger the scale of the database cluster, but also the bigger the resilience. If you scale out to an additional region to reach additional customers, you also have the benefit of being able to fail over into that region automatically. I'll now demo two different ways of running a database. One is with a disaster recovery mindset. I wouldn't recommend running CockroachDB like this in production. And the second is to demonstrate a disaster prevention mindset. This is a much better fit for Cockroach, as that's the way it's been architected as a distributed SQL database. This is part one of the demo. This is disaster recovery. Again, I wouldn't recommend doing this. I have two clusters, a primary and a secondary. In the primary, I've got nodes 1, 2, and 3, and they'll be fronted by an HA proxy, which looks like this. The three nodes expose their 26257 port on 26001, 002, and 003 respectively. And you can see that I've got a secondary cluster ready to go once I've killed the primary cluster. Secondary is exactly the same, just with nodes 4, different ports, nodes 5, node 6. I'm running a very simple Go app that connects to the database via the exposed HA proxy port of 26257 and runs a select now. If it succeeds, I add it to a count. If it fails, I add it to another count. And it's to simulate, while being hideously contrived, real-world use of the database. I'll start my primary cluster and I'll create a database. I'm not actually using the database, but I will be connecting to this database and it'll be useful to make a point in a minute. I'll start my secondary cluster. And now I'll create two external connections, one for each of the clusters. This will just allow me to run backup and restore operations without using my credentials. I'll start the load balancer and I'll start my application. We can see that all of the requests are currently successful. I'm simulating an online retail store with all the requests generating between £0 and £50. We've made around 1,200 requests and we've brought in around £40,000. I'll make a backup of the database. I'm not actually using the database, so there's nothing to back up. If this were a real scenario, you'd want to be making incremental backups because a full backup takes a long time. In the scenario where you've got an idle data center ready for disaster recovery, your recovery time objective, your RTO, is very much going to depend on the size of your backup. If you've got a huge multi-terabyte backup, you're going to need to wait for that backup to complete before you can resume business. So that's something else you're going to have to factor into your disaster recovery scenario. And another reason I would urge a disaster prevention mindset over a disaster recovery mindset. I'll make the backup, and this is very best case scenario. This is a backup that's been made just before everything goes down. I know that everything's going to go down because I'm going to cause everything to go down. In the real world, you don't know when everything's going to go down, so you need to have a good cadence behind your backups. And even with a disaster prevention mindset, things can still go wrong. So keep making regular backups with regular incremental backups between them. Now I'm going to stop nodes 1, 2, and 3. And we're going to see very, very quickly that all of the requests are now failing. And I'm counting up the number of requests and the amount of money that we're losing as a result of this. So I'll be quick now. Let's get panic hat on. First, I'll need to get the secondary database up to date with the primary database. So this is going to be our restore operation. Depending on how big your backup set is, this could take hours. And I'll swap over the HA proxy to be pointing to the secondary cluster. I know it's a scenario, but I'm still panicking. I'll kill the HA proxy so that it starts to route to the new cluster. So now we're talking to our secondary cluster, and MUN is coming in again now. But during our failure window, which actually lasted only maybe 40 seconds, 50 seconds, we lost £131,000. Now you've got a second difficult decision to make. Do you fail back to the primary, or do you stay running with the secondary? Because there's risks involved in any kind of failover scenario. What I'll first do is simulate everything coming back up again. So we'll do a docker start node 123. I'll revert my change to the HA proxy configuration, and I'll flip the config back to point to the primary infrastructure. And just to prove that it's working, I'll stop nodes 4, 5, and 6, and everything's still working against the primary infrastructure. Needless to say, an expensive outage. Now I'll do the same thing, but with a disaster prevention mindset. In this example, rather than having 2 separate clusters with 3 nodes each, I've got one big cluster with 6 nodes. Node 1 through 6, and each node will expose its 26257 port via a different port number for HA proxy. And that's what the HA proxy configuration looks like. I'll start the cluster. I'll create a database, but as with the previous example, that's only for my client to connect to. I'll start HA proxy, and I'll start the Go application. Now with the previous example, I'm going to simulate knocking out nodes 1, 2, and 3. We did fail to make a request, and that's because we trapped an in-flight request and it failed. But in any scenario where you're dealing with a serializable isolation database, you should be making retries anyway. Ultimately, it's less than 100,000. So that's our 3 nodes down at the moment. I'll bring those back up again. And I'll knock out nodes 4, 5, and 6. We've lost another one, but it's looking much better. I've taken out all 6 nodes of the cluster in 2 groups of 3, and the cluster is still running. So in summary, disaster prevention and disaster recovery are very different models of surviving an outage. It's my opinion that disaster recovery is a mindset of, I hope it doesn't break, but I know that I've got people who should be able to fix it in the event that it does break. Whereas the disaster prevention mindset is, I believe, a more modern mindset, and especially helped by tools like distributed SQL. I rely on having one instance of my infrastructure that can self-heal, reducing the amount of manual intervention by sleepy engineers at 2 a.m. when they've just received a page.